do because it's quicker. Yes, and again, the enemy of you going to the college you want to go to is what? Time, right. So if you can just, in fact, if they're nice enough to give you multiple choice answers, just plug in and see which one works. As soon as you get one that works, you're done. Move on to the next one. In fact, Matt, I would say that's the best strategy for that one because it takes the least amount of time. Now, if you want to feel good about yourself after the test, you can go solve it at home, but because Mrs. Kumar taught you better than that. But on a standardized test, this is really, in fact, I'm going to go back to this real quick. This is why I emphasize this. We at DCC do an amazing job of getting you ready to take school tests, which is great. You go to college prepared and ready. A standardized test is not a school test at all. It is a totally different ballgame. And you got to walk into that ice cold ready to take a standardized test, not ready to take a school test. Because a lot of our kids, 4.6 GPA, 22 highest college that they want to, that's not an automatic admission. Like CSU, automatic admission. You're good. Everyone in this room, you're going to apply as long as you pay, you're going to get in. Like BYU, not automatic admission, very competitive admission. Stanford, very competitive admission. If your GPA is up here, your test scores are here, you might as well not even have that GPA. They're just going to look at that test score and there's no way you're getting in. Why? A lot of it is because kids take tests like they take school tests. Be thinking time is my enemy. I don't care about 90%. I care about time. Because you get 3 out of 4, 75%, you got a pretty good score. You do better than that, you're going to get a great score. But there's no way you're going to get a 90% working every problem like a school test. I'm going to do number 1, and then number 2, and then number 3, and then no. Number 3 is going to take you 5 minutes. You skip and move on. Like it's a waste of time. You can get 5 points. Why would you get 5 points when you can get 1? You wouldn't. So you have to walk into this thinking it's a different ballgame. Showing your work is actually against you because it takes time. If you don't have to show your work, don't do it on these tests. Just figure out what answer's right. In fact, even better, Josh, the only other better strategy I could think of is if you could just type it into the super calculator, hit intersect, and boom, you know the answer right away. But that might even take a little bit more time.
Actually, I got a question. Do they allow CASs on the ACT?
On the SAT, yes. On the ACT, no.
Oh, that's bad.
I can't believe they let you use that calculator on there, but they do, so you might as well use it. I'm not going to lie to you, and I'll tell this story again, and sadly, I have Rhea. Rhea was in Calc BC last year when this day occurred. She can vouch for it. Everybody remember that foreign exchange student, Zoe, last year? She as a Christmas present from her parents, because in Australia they have like a big holiday break then. She takes this test. This test should take an hour and a half. Like it took me an hour to take this test. She's done like 5 minutes. So I go up to her and I was like, oh, you forgot we had a test today? She's like, no, I got 100%. I was like, how do you know you got 100%? She's like, just typed all these in my calculator. I was like, what? No, you can't do that. She's like, I'll show you. So then, of course, I'm like, okay, you can't use that on the AP test. You got to use a real calculator. So then, of course, I go, look at it. I was like, you can. So then I emailed Mrs. Thurkel up at LP. She's a grader for the AP test, which is easy for a lot of things. But for math, you have to have 5 years of an average score of 4 or higher just to apply. So it's really competitive. I emailed her, and she's like, yeah, tell your students to get it. It's brand new, just came out. It's awesome. Tell them to get it. It's a big advantage. And then magically by Valentine's Day, almost everybody had one. So I don't know why on Valentine's Day a lot of people got one. Go figure. Number 8, 7.
6.
Oh, sorry.
1, 2.
Good job, Josh. Number 7. No, number 6.
Okay, good. So we have about 500 gallons. We're supposed to find out how many bottles it takes to fill up 4 gallons. So you 600 gallons to ounces, 500 times 128, and divide by 20 ounces per bottle. You plug in the calculator, you get 32 bottles. The answer is D. What questions do you have?
1, 2.
All right, and number 7, Mr. Neal.
Got a car, it's going 80 miles an hour. It goes 80 miles an hour for 3 hours, which is unrealistic. It gets 34 miles per gallon fuel efficiency. We need to find out how many gallons of fuel it consumed. Multiply 80 by 3, got 240 miles it's been traveling. Divide 230 by 34 miles a gallon, you get 7 gallons of fuel. Any questions?
That's not that unrealistic.
Yeah, I literally did that.
I feel like that's the drive to go.
Okay, question. Hold on. Does it matter if it's realistic?
No,
Well, he
I'm
said
not
it was.
doing
That's why I say I did that on Monday, so it's not.
Well, where's the speed limit 80? And if you're doing it for 3 hours, you're probably going to see
That's
more.
5
I was
over.
5 over.
Not going through.
That's from here to Cheyenne, Wyoming. 5 over. That's nothing.
You just believe when you get to Denver.
But then traffic too.
It wasn't
Yeah,
at
yeah.
It's good. What?
80 miles an hour all the way to Utah. I wasn't even going on the speed.
Oh wow, it's cool.
Yeah, Utah does have 80 miles.
1, 2.
All right, take your homework. Let's look at. I'm surprised there's not more. Are there more?
I got you. I said,
Seriously, there's not more? Like I said, every day I expect you to come back with what? Surprise, there's not more. Do we need to do a brief review of big things in this class?
what is that?
You guys talk. I know I've been gone. Just coincidental, both days I've been gone. I've been on silver days, and they've both been on days that we talk about relatively large topics. I don't want to leave children behind though, because I try to give the video. Oh, that's the one I wanted, Lena. Is that from the AP section? That's the one I was really expecting questions on, because one of you, and I kind of called out that you hadn't done the homework because that was an amazing question. Number 10 is really good. So did you not get that far, or you totally got it? Like, go on faster.
I understood.
Okay, good. Okay, let's take a look briefly. I want to look at 104 first, because 104 is a great problem. 104. 104. I'm not on the screen for some reason, though. That's not good. 104. 104. The function f of x is equal to, okay, what's that symbol on the top? Absolute value of x. What is absolute value? It's a really lazy way of writing what? Piecewise function. Right. If you see absolute value, you must think this is a really lazy way of writing a piecewise function. And absolute value is a piecewise function. In fact, we're going to find it out in just a second. If you don't know that off the top of your head, remember how I told you to front cover your notebook? That's a really convenient spot to write things that like I'm going to have to remember throughout this class, but I don't want to go like digging through my notes for it. This is one of those things. We've got to say, explain why is it impossible to divide f of 0 so that it's continuous at 0? Well, let's look at absolute value first. Oh, I told Ashley I'd write it underneath there. So I need to write it underneath there. Because she can't see it if I'm on there. All right, so let's take a peek. For some reason I have 0 viewers, which bothers me, but okay, that's what we're going to be talking about today. I did send out the link, right? Somebody text me. Could somebody just test make sure it works real quick? Okay, so I have the absolute value of x divided by x. Okay, now if you plug in 0, it's undefined because the denominator is equal to 0. And can we just cancel out that x? Yeah, if it, oh, the link does good. Okay, if we cancel out the x's, we still get a hole in the graph. But a lot of holes, we can just replace a value for f of 0 and make it continuous for. So let's go back to what is absolute value. Well, the absolute value I mentioned is a piecewise function. Absolute value of x. Well, there's one rule when x is what?
I'm so sorry. It loaded.
Thank you. There's one value when x is what?
When x is
Positive, right, which means it's greater than or equal to 0, right. In fact, if you plug in a number that's greater than or equal to 0, what do you get back? Just x, right. If you plug in 4, you get back 4. You plug in 8, you get back 8. Plug in 1.25, you get back 1.25. But when x is negative, like you plug in -1, what is the absolute value of that? 1. So what do you have to multiply the negative numbers by to make them all positive? -1. -1 times x. If you didn't know that off the top of your head, write that down in the front cover of your notebook so it's there somewhere that you don't have to look this up every time you get it, because this is what absolute value is. It's a very lazy way of writing a piecewise function. Noah, after this problem, I do need to show you what I need to do today, because I got to have you do that. I'm behind on that. What do we do with that then? Okay, well, what's the graph of that look like? Well, it looks like that. Ariana was making that as soon as I mentioned it. Well, let me ask you a question. Is that continuous at x equals 0? Okay, that was a very low response rate. Really? What's the absolute value? Hold on. What's the absolute value of 0? Right. Is that a continuous function? Okay, let's go back to the definition, because as soon as you hear continuity, you need to think 3 things. Does the limit exist at x equals 0? Yes, because the limit from the left and the limit from the right are equal. Right. They're equal. They're both 0, but they're equal to each other. Does f of 0 exist? Yes. Is the limit equal to f of 0? Yes. So is it continuous at x equals 0? Yes. So then you're like, why is this question asking this? But then you remember it's taking the absolute value and dividing it by what? X. So here's the bad news. The absolute value is always going to be what? Positive. So now let's look at the actual problem. Absolute value of x divided by x. Okay. If you plug in a positive number, you're going to have a positive number divided by a positive number, which is always going to give you what answer? Positive. In fact, it's going to give you what? 1, right. You okay?
Yeah.
Okay. You look like the answer was going to make you puke. I didn't want you to puke.
Just choke.
Okay. Oh, even
Yeah, I
worse,
know.
choking.
I was like, did you sneeze?
Well, I didn't know. I thought the answer was so powerful to you that you're going to pick it up. So from the right, it's going to 1. From the left, you're going to have if you plug in a negative number, the top is going to be what? And the bottom's going to be? Right. You really like your boyfriend. He dumps you on Instagram. Is that positive or negative for you?
Positive.
Negative, right. So it's going towards -1. Now, here's the problem, though. When you plug in 0, what happens? 0 over 0, which is undefined for now. We'll make it more complicated later on. You remember your friend the Hobbit from last year. We'll make it more complicated later on. Now, the problem is, what type of discontinuity is this? What type of discontinuity is this? It's not removable because it's starts with J, rhymes with jump discontinuity. There's nothing we can define f of 0 to be because it would violate which part of the continuity criteria? The definition of continuity has 3 parts to it. A jump discontinuity, we can't do anything to fix one of those 3. What's the
Limit.
The limit does not exist because the limit from the right and the limit from the left are not what? Equal to each other. So no, why? Because it's a jump, because the limit from the left does not equal the limit from the right. So there's nothing we can do to fix that. Where you think the relationship is going, where your boyfriend thinks the relationship going are 2 different places. We can't fix that. Yes, Ayana.
So for AP, if you just said that it doesn't contain a removable discontinuity.
If you wrote this right here, and I got to put not equal, ha, 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 that you get full credit. The limit from the right does not equal the limit from the left, so we can't make it continuous. And again, the AP, just like me, is very specific on you knowing the definitions of what these things mean. If you need to make flashcards of this, because if you're seeing at this point, I can't remember this, make some flashcards at this point. Continuity, 3 things of continuity. Limit to exist, the things that happen to have the limit to exist. Because for the limit to exist, the limit from the left has to be equal to the limit from the right. Does it matter what happens at the point? No, it doesn't even matter if it exists or not. If you feel like this is a lot of stuff that I need to memorize, make flashcards now because you're going to have to make flashcards later. I will make you make flashcards later on. You might as well get started now and just keep these ideas in your head. Because AP is a very specific language. Calculus is a very specific language. And knowing the criteria that has to exist, whether you go to college at Harvard next year, you go to Pikes Peak Community College, they're going to use the same vocab that I'm using in class. Because you walk into Breebach, you're like, Breebach, what are the 3 conditions for a function to be continuous at a point? You would say?
Limit. Yes. Evaluate. And.
Yeah. So if you didn't know, not only am I saying that, but some random guy walking off the street into my classroom even knows what those are. So, Mr. Breebach, what's up, sir?
Nothing. I just heard you talk about limit approaching from the left, limit approaching from the right, and I wanted to hear what was up.
Well, Breebach, would you agree or disagree that the language of mathematics is as important as the computation of mathematics?
I disagree.
Which one's more important?
Ooh.
Oof. You got to pick one out.
Can't I just make it equal something? It can't be an equation.
You could make it an inequality if you want
Value of
to.
the language of mathematics is equal to the value of the computation. Steps of mathematics. Gotta have both.
Gotcha. Let's take a look at those AP
I probably
questions.
didn't demonstrate that when I walked in and went limit, evaluate, read. That probably didn't help anyone.
Rigorous vocabulary.
Yeah, put that idiot on YouTube.
Yeah, it is. Number 10, we got this AP question. The function f is continuous on the closed interval -2 to 2. Several values. And if how many took AB last year? You know, they love the table, and they love to throw something at you that makes it meet some criteria that they've established. And this is a perfect typical example. So you've got the function is continuous on this closed interval. Several values are listed, but now we talked about the intermediate value theorem only guarantees how many points? 1. But now they want you to do something else. So they say the equation f of x is equal to 1 must have at least 2 solutions on the interval -2 to 2 if c is equal to what? Now we say f of a and f of b, one of them is bigger than the other. If f of a is the bigger one, f of b is the lower one. If it's continuous between that, we guarantee every value between f of a and f of b exists. There's some c we could plug in that could give us everything between the top and the lower. Like if the top is 4 and the bottom is 2, it's continuous between those 2 values. Every value between 2 and 4, there's something you could plug in to get that out. Now, look at this one, and they want us to find 2 of them. Question. If it's equal to 4, is there any hope? No, because there's 2, 3, 4. We want to know 1. It doesn't even guarantee that it exists. It could get there, it could not. I mean, it could just be going down the whole time and never get to 1. It could be going up the whole time and never get to 1. What about 3? Does that help us out? Okay, now let's look at B. If it's equal to 1, that would guarantee what? 1 point, but it wouldn't guarantee what? 2. But 1/2 guarantees 2. Why does it guarantee 2?
Because
Only using the language of the intermediate value theorem. Only using the language of the intermediate value theorem. Yes, Caleb.
According to the intermediate value theory, you have a point A and a point B.
Yep.
And the function is continuous between those 2 points.
Yep.
And your point C is 1/2 in between those 2 points, A and B.
Yep.
Then it would have to cross, because it's continuous.
Yep.
It would have to cross the f of x equals f of c equals 1.
Yep.
Twice.
Okay, I drew a diagram of that up here. So here's f of x is equal to 1. If it goes beneath it, it had to go from 3 down to 1/2, and then it has to go from 1/2, or excuse me, is it 4 or 3? It is from 3 down to 1/2, and then from 1/2 back up to 2. If you break that into 2 intervals, to the left, how many times does it have to hit it in here? To the right, how many times does it have to hit it in there? 1. So that's how you do your 2. So if you break it up into 2 intervals, the intermediate value theorem says it would have to hit 1 to go from 3 to 1/2, and it would have to hit 1 to go from 1/2 to 2. And that's how you use the intermediate value theorem to guarantee there's 2 points. It has to go beneath it, though. Now, does it have to go to 1/2? No. In fact, question to you, what's the interval of solutions that C could be? So instead of just what's one number, what's the interval solutions? Everything from what to what? Caleb?
It would have to be from C is the input value.
No, C is the output. C is the output. 0 is the
Oh,
input.
sorry, C is the
So
output value.
C could be between what 2 numbers?
1
Okay.
and then 2.
No. Somebody else. Anna.
-2.
Nope. Nick.
negative infinity up towards 1.
Right. Would it be a closed or an open parenthesis at 1?
Normal.
Of course. Do I ever just tell you something and not explain it, girl? No, of course not. What kind of teacher does that? Like, seriously, what kind of teacher does that? Teachers that don't know how to explain stuff. Yes. Yeah. Okay, so he says negative. So C could be any value from negative infinity and then closed or open parenthesis at 1. Open parenthesis. Why an open parenthesis?
Because it doesn't indicate 1.
Right. So C has to be some number that is less than 1. It could be 0.99999 repeating and then an 8 at the end. Couldn't be 0.9 repeating, correct? But it has to go beneath 1. Now, does it matter how far it goes beneath 1? No, but C could be anything from all the way down from negative infinity to 1 with a open parenthesis at both because it has to go below 1. If it's just equal to 1, then we could only have it 1 time. It has to go below 1. It could be C could be anything from negative infinity to 1. Notice how we did the same question last period, but I explained a very much simpler one last period and totally different one this period. Questions on that?
Why does it have to go below 1?
Because if it just hits 1, it could go to 1, hit it, and bounce back up, and it can only hit it 1 time. And this question says it has to hit it 2 times. So it has to go below and then back above. So it has to actually go below 1. It can't just be equal to 1. And a closed bracket would mean that it's equal to 1. So it has to be an open bracket, which is way beyond the scope of that question, but such a fun question to answer. You can't ignore it.
But couldn't it hit again between 1 and 2?
It could,
So,
but it doesn't guarantee it. This is Amazon Prime, Ayana. This guarantees it's going to be there in 2 days.
okay.
It could arrive in 1 day. It could, they could come deliver it to your house. But the intermediate value theorem has a guarantee behind it. It's
That's why I was
guaranteeing.
confused. Okay.
Yeah.
I was like, they both could. But
Could be, but
One
could be
time.
isn't very powerful, Ayana.
Definitely.
If you go up to somebody and like, I could marry you. I could. That's not very good. If you like, I guarantee if you ask me, I'm gonna marry you. There's a guarantee. Yeah. Yeah, one's got the ring in front of you. One's just saying I could. One's a lot more powerful than the other. Guarantees are very powerful. All right, other number 6. Let's look at that one real quick, and then we'll take a daily quiz and make you suffer. Okay, f of x is equal to x cubed minus 2x plus 5. If f of c is equal to 0 for only one real number c, then c is between what? C is between what? Well, in this one, there are 2 types of questions on the AP Calc test. Ones that you have to use your calculator and ones that you can't. Does this one say no calculator? No, it doesn't. So let's type it into our calculator real quick. let's type it into our calculator real quick. So let's go. Y is equal to, what do I got here? This is a terrible angle, though. Terrible, terrible. Let's type it in. X cubed. Now, of course, those of you that have the super calculator, at some point soon, I will switch to the super calculator, but it's not there yet. Minus 2x plus 5. Okay, so I go to Zoom standard. I always do that. That's just good advice. Okay, now you only wanted to have how many solutions? 1. Now, it seems like it's going to hit there where? It's going to hit, yeah, it seems like it's going to hit right there. So let's see. If we go between -4 and -2, is it going to have more than one solution? Yep, so we want f of c to equal 0 for only one value c. Then c is between, now notice it's between, what you notice? Yep. Oh, you can't see that. So you can't, you want to see the actual question. It has to be between what? Well, let's eliminate some easy ones first. Is there a value between -1 and 1 that it crosses? Is there a value between -1 and 1? No. -1 is right there. 1 is right there. No. So that one's out. What about 1 and 3? From 1 to 3? No. What about -2 and -1? Well, we got to investigate a little bit. Where is that? Where is that? How do we calculate where the zeros are using our friend the calculator? Second. Yep. And then you go to what? 0. And then it's going to ask you, where is it in between? So you got to go to the left and to the right. So you left bound, enter, right bound, enter. So, okay, we wanted to find the one that's between there and there. Guess doesn't really matter. It's at -2.09.
So no.
So is it between those two? No, so it has to be A. And notice I use process of elimination, which is just as good as actually figuring out the problem. All right, take your desk. Back and link them between you and the person standing next to you. Take your homework. Actually, hold on. Here's what I need you to do today. I need you to count how many you didn't do. That's it. Count how many you didn't do.
0. Mr. Beckman, I got a question.
Count how many you didn't do. I'm going to call on you. You get to do one of two things. Either tell me how many you didn't do or come up and show me how many you didn't do. But I got a great homework quick because I got to have Noah. I got to train him today, so I got to get him used to the Beckman system. Ayana.
So in the book, I read it and it said that the intermediate value theorem.
Yep.
It says that f of A and f of B have to have opposite signs.
No, they can't be. It says they can't be equal to each other.
No, but like it says opposite signs.
Let me look.
And I was so confused, so I wrote like a note to myself to ask.
Girl, no. Teachers get paid to answer questions. Why are you apologizing for that? Teachers get paid to answer questions. The intermediate value theorem. And let f of x be continuous on the closed interval between a of b with f of a not equal to f of b. Then there is, if there is any number n between f of a and f of b, then there's at least one number n. There's at least one number on the open interval a to b for which f of c is equal to n. So in other words, there's a value component for x for everything. Where's the opposite signs?
It was in the example.
Oh, in the example.
It was
All right.
weird. It said something like somewhere over there.
This particular one, they just happen to have opposite signs. So it goes from negative to positive, so it had to cross 0 at some point. If it
But it
goes,
says that because they have the opposite signs.
Yep.
It states that.
Yep. Which is exactly what I was using on the graph, because it goes from below the x-axis to above the x-axis.
Does it have to?
No, necessarily. But if it's going to go from, if it's going to cross 0, it either has to go from positive to negative or negative to positive. One of the two.
So it has to cross 0.
Right. For the intermediate value theorem to apply. Now, does the intermediate value theorem only work when f of x is equal to 0? No, it works for everything. That's just a particular case. Okay. Yeah. Like, you know, you go to the ER, there's a, you know, some patient comes in, they got one of them off, they said, cut every pin really hard. Good job. Number one, you want hard quizzes. Hard quizzes get you ready for Beckman's hard test. F of x.
Yeah.
Oh, yeah, I'm going to call on you. I'm just going to say, like, Matt, how many did you not do?
0.
Okay, I'm just calling you during the quiz. Now, you don't have to say it out loud. You just come up, but he's not ready to grade homework yet, and I need him to do something else saying this. Okay, number one, f of x is equal to, oh, you asked for a hard one. Let's give you a hard one. Let's go for x squared Oh, what should we go for? Minus 3x plus 1. Let me graph that real quick so I make sure I'm not stupid. X squared minus.
Is calculator no calculator?
It's always calculator and it's always open note. We're still learning. When I give you a test, we ain't learning no more. Yeah. Oh, yeah. There we go. Okay, and we're going to look on the interval. Let's go from 0 to 9. Oh, yeah. Let's go for that. That's beautiful. 0 to 3. Show that there must be a C in the interval from 0 to 3 such that f of C is equal to 1/3. Ooh. F of C. Oh, no. Hold on. Is that going to work? Hold on a second. Let's change that to 2. 2. Yeah, 2. From 0 to 2 to show that there must be a C such that f of C is equal to 1/3. And then number 2, so that's worth 2 points. In other words, there's going to be 2 things you have to show me to show that there exists some C that does that. And then part 2, 3 decimal places. Find a C. Now question, could there be more than 1?
Yes.
There could be 7. But part A is going to guarantee that there's at least what? 1. Could there be more than 1? Of course there could. That's it. 3 points today. Ready, set, math. 2 for number 1, 1 for number 2. Kisley, I got to have you do something real quick. Kisley, I'm going to choose a calendar right now. I got to grade some very, really heavy grades. Here's the answer. Here's the answer. You're going to be commenting on yours. So, my team is going to go through and highlight the ones that draw. You try to find their errors. You can't. You're in calc. Very confident. Good. So you're going to try to find their errors. Now, out of 3, what I try to do is some sort of 2 times 1 pointed off, take a second. 3 points, you're close to F4, half to F4. But what you're trying to do is find that error. So in this one, that's correct. They should square that. So if they do, they can have to square it. Oh, they can actually get an hour. So try to put a comment on something you did wrong, and then get points off each other. Good, Brendan? Several. Okay, so that's a negative, that's not a negative. Really? Darn it. So that means you'll have to check every number 11 manually. All right. Darn it. Good catch. Scott Rogers, Megan Fox. Yes. Yes, you have to.
Well, you could do something else.
I think you believed in yourself.
In the book, it says to do something else. with that.
Yeah, you have to like keep like doing from each side until you get 3 decimals. That's why.
That's what I'm doing currently.
Don't do that.
I'm
That's
almost
such
done
a.
now. Like I promise us, leave me alone.
Sean, if you want to do that at home for fun to avoid using drugs, you do that, buddy.
Right.
answers to this here quiz, and we'll go on.
Can you make candies over to Lulu? I would love to make those. Okay,
I don't know if we just have I did feel like.
All right, number one, you got to have two. Oh, we'll wait for Willows. You got all of them? Can you hand them my wonderful TA, please? Number one, f of x equal to x squared minus 3x plus 1 on the interval 0 to 2. Show that there is. Now, if I would have made the interval 0 to 3, that would have been a tricky one, because then the intermediate value theorem wouldn't have what? Applied, because what's f of 3? Bigger than f of 1. In fact, I think it's actually equal to f of 0. So then the intermediate value theorem would apply. But that was nice. I decided not to trick you. So 0 to 2, show that it applies. So number one, what's the two things you have to have? Well, f of x is what kind of function? Yes, you must have that. Now, a polynomial is continuous. We don't care it's a polynomial. We care it's what? Continuous, right? The very definition of that. You must have f of x is continuous. If it's not continuous, it could jump between one and the other. If it's not continuous, it could jump, and then the intermediate value theorem doesn't apply. So number one, you must have it's continuous. And number two, you must have f of 0 is equal to what? 1. F of 2 is equal to? Negative 1. Is it negative 1? Okay. Negative 1. Negative 1. So therefore, there has to be an f of c such that it's equal to 1/2 by the intermediate value theorem.
What if you wrote
Oh,
out
1/3. That's a 3.
I mean,
That's
it
obviously.
doesn't matter.
Doesn't matter. Okay, this is a precise language. It matters. It matters. All right.
Still an f of c that equals 1/2.
Hey, number two, what are the two? I think there's two of them, right?
Yeah.
What are the two values?
Well,
You said two, but
I think there's,
you said
you only have to
one.
find one, but what are the two values? X can equal what? Okay, let's, who borrowed my calculator?
Definitely.
Oh, it's right here. Never mind. Okay, 0 point what? Lena, or excuse me, Napur. 2.2? 242. What's the other one?
Is that in the domain of such?
2.76.
2.76. Yep. So the only one that meets it is. But that's out of 3 points. Anybody get all three? Yay, let's get smarter today. We have a plethora to learn. 1.4.
What do we do with homework?
Nothing. You keep it. At the end of the chapter, remember you got to turn in all your homework, so don't throw it away. Trig limits. Those are really fun. Sandwich theorem. Really fun. That should be a great memory from last year. There was me. There was my girlfriend. There's her annoying friend that's always sandwiched in between us. Hashtag sandwich theorem, but now we apply it to limits. Okay, so number one thing, you only know two limits at this point. You only know two limits. The first one is the limit of a what? Constant is the constant, right. If it's a constant function, y is equal to 7. What are you always getting close to? 7, right. And then you also know the limit of a linear. The limit as x approaches a of x is equal to what? That was to you. A, right. Why? Because wherever you're going on a straight line, whatever y x value you're getting close to, the y value is getting close to that same value. Okay, we're going to add to that right now. And now, I mentioned this to last period. Every calculus teacher in the entire country dreams of their kids knowing everything about trig walking in the door. If you took this, in fact, there's a girl named Kaylee who graduated last year. She went to Utah State. The first thing they asked her in her calculus class is, did you take our trig class last semester? And of course, most of the kids say, no, I took it in high school. And they're like, oh, no, you didn't. They make you take like an entire semester of trig. Why? Because that is the thing that kills kids in calc, is the little things they just don't remember from trig. Today is one of those days. Hey, and by the way, Cameron McCutcheon, I got something for you. Who's that one for? Chaudhary, got something for you. Ooh, this feels like cash.
It better be.
Is it cash?
Shh. Caleb, America.
The thing is, don't tell anyone. These people are horrible.
Well, don't worry. It's on the internet. No problem. Okay, we're going to add to that. Number 3, the limit as x approaches 0 of the sine of x. Now, let's think back. The sine of x, what happens as you get really close to 0? It's getting close to 0, right. Those. Yes, we are adding in two more things that we're going to know the limit of starting today. Number 1 is the sine of x. As x gets really close to 0, the sine of x is getting close to 0. If you took my honors FST, my honors pre-calc, any of those classes, you remember that I defined sine and cosine as the ratio. Ratio. Sine is the ratio of how much vertical distance you have to the total distance you're going. If you're going 0 degrees, how much vertical do you have? 0, right, because you're going straight in front of you. You're not going up, you're not going down, you're just going straight. What cosine I defined as the percent of horizontal motion you have. If you're going straight forward, 0 degrees, how much of that is horizontal motion? All of it, right. So that's the two we're adding in today. The limit as x approaches 0 of sine is equal to 0. The limit as x approaches 0 of cosine is equal to 1. Those are the only two we're adding in today. Now, the rest is algebra tricks. And there is a plethora of algebra tricks in this section. I hate to break it to you, but a lot of what we go into now is just remembering the glory days of algebra. But before we do that, any questions on that? Then we are reminded of a tricky one. I taught you this at the start of the year. The limit as x approaches 0 of sine x over x was equal to what? 1, right. That's just one of those that they expect you to remember all the time because this is one of those tricky ones. Because you feel like the answer is going to be what? The answer is going to be, well, what's sine going to? 0. What's x going to? 0. So what's 0 over 0 going to go to? Oh, depends. You better have that word in your head. 0 over 0 depends. How fast is the top going to 0? How fast is the bottom going to 0? Just like infinity over infinity. What's your answer? It's not 1. It depends on how fast we're going to infinity on the top and how fast we're going to infinity on the bottom. Okay, so let's go to algebra. Okay, I'm going to remind you of an algebra trick. It is literally an algebra trick. So then you get in example number 1. The limit as x goes to 0 of sine of 3x over x. And you're like, oh, hot dog. I just wish the bottom was what? 3x. But it's not. So I want you to stop and think real quick. How can we get a 3 on the bottom? How can we get a 3 on the bottom? Ideas. Talk to the person next to you real quick. How can we get a 3 on the bottom? How can we get a 3 on the bottom? Or I have no idea. Please show me. Like I don't remember that day in calc last year or in pre-calc. Or my pre-calc teacher was back when he never covered that. Volunteer. Ideas. Shottery, what do we do? Yeah, multiply. Because you can multiply by 1. Does multiplying by 1 change the limit? Oh, math, no, it doesn't. Multiply the top and the bottom by 3. Beautiful. 3 over 3, that doesn't change anything. So we've got the limit as x goes to 0 of 3 sine of 3x over 3x. It'd be beautiful. Look up real quick. Look up. It'd be beautiful if we just had that. It'd be beautiful if we just had that. What can we do with that 3? Yeah, we move it outside. Remember, back to the properties of limits. We can move 3's outside. That's how bad the breakup is when you have a constant. You got 3 times the limit as x approaches 0 of sine 3x over 3x. Right? Now, question. We didn't exactly do that before. We didn't. So we're going to make a u substitution with this puppy. And that goes, again, back to pre-calc. We're going to make a u sub. In other words, we're going to get rid of something we don't like with something we do like. We're going to get rid of something we don't like with something we do like. What's something we do like? If instead of 3x, it was just like what? T, Q, U. Right. So we're going to let t, or whatever variable you want, or u. It's called the u sub because you usually use u. T is equal to 3x. That means we can replace all of the x's with what? T's. Which one are you going to forget about, though? Ooh, think about that real quick. All of the x has got to be replaced with t's. Which x are you going to forget about, though? Which x are you going to forget about? Anybody, ideas? Which x? Yeah, talk to the person next to you real quick. Which x are we going to forget about? Which x are we going to forget about? That's going to be bad news bears if we do. Volunteer, which one are we going to forget about, Cameron? Right. Well, don't forget, if you replace that x and that x, suddenly you're taking an x, we're taking a limit with respect to t now. You got to replace that one too. So let's talk about what we do. So first we're going to have 3 times the limit. Notice I'm not writing what's beneath it yet. Of sine of t over t. Now let's, as x goes to 0, if the x is going to 0, what's this getting close to? 0, right. So we can just replace it with t is equal to 0. Now let me ask you another question. If this was 3x plus 2, 3x plus 2, what would this be getting close to? 2, right. So we'd have to replace the t with a 2. T would be getting close to 2. So we do have to replace all of them with it, but we also have to think about what the limit's going to take that to. Now, good news. What's the limit of sine t over t as t goes to 0? So we just have 3 times 1. Notice I'm not writing the limit anymore, and you're really smart. What's 3 times 1? 3. Yay. Stop and check up. Questions on that? Chaudhry.
I understand that the use of is y sine 3x over 3x
Yep.
is, but if sine of whatever over whatever is that, we just assume that it's going to be 1.
Yes, you can. Cameron.
Can you show us why this sign T over T?
Why sine t over t works? Because you got the same thing on top, same thing on the bottom, and that thing's going to 0. And L'Hopital's is the proof that we will do later on, but we don't know L'Hopital's yet. All we know so far is that as we get infinitely close to 0, sine of whatever over whatever is getting really close to 1. Yep.
I don't understand why you just replace X with 3.
Are you ready for this? You could replace X with whatever you wanted to. Any other variable except what? X, right? Because then you'd be using the same variable twice. Now, why do we do that? So we get it into a familiar form. But you can replace any variable.
T
Yep.
is 3x.
Yep.
Not X.
Right.
So I can replace X, which is not 3x, not 3x.
Are you talking about this X?
Yes.
Because what is that getting really close to as X gets close to 0? 3 times something is getting really close to 0. So if this is getting really close to 0 and they're equal, what is this got to be getting really close to? 0 as well. And that's why I put in the caveat. If it was 3x plus 2, what would this be getting really close to? 2. So I'd have to replace not the limit as t goes to 0, but the limit as t goes to 2. Yeah, Cameron.
X was approaching.
What's that?
X was approaching.
So then t would be approaching 6. 3 times 2.
So then you have
Yeah, t is approaching 6. Yeah. I mean, you remember doing that with integrals last year, correct? Like if you replaced a variable with another variable, you had to change the integrand limits too. I got one.
No, we did have to change.
Of course you have to, because now you're saying this is no longer a problem that's dependent on X. It's a problem that's dependent on this other thing. We have to switch everything over to that other thing. Whether it's, and really, Ayana, don't let the letter hang you up. T, U, K, R, whatever you want to. Yep. Now, you do have to define it. Now, some of you noticed there was an AP question last year that you guys got nailed on because they were asked, I remember the two asking me, like, what if they don't define it? You don't define it. Nobody knows what you're talking about. So you must say t is equal to 3x to use that substitution. Or, you know, theta is equal to blah, 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 blah. But you do have to tell people, because, again, your grader's going to assume you know nothing. They're just going to see what you show them. You got to show them everything you know, or everything you're trying to do. Other questions on that one? Let's show you another algebra trick, and then the homework's just loaded full of algebra tricks tonight. But let's show you another one. Example number 2. What about this dog? What about limit? I don't know. As let's go for theta goes to 0 of sine of. What do you want, an easy one or hard one? Arabella, what do you think? Easy one or hard one? What's that? Hard. Let's go for sine of 7 theta over the sine of 3 theta. Ooh. Okay, just dissect this one real quick. Before we go and try to triage this patient here, let's see what we got going on. Let's see what we got going on here. See what we got going on. Ooh, can I break up the top and the bottom? Can I just break it up into the limit of the top over the limit of the bottom? No, why not? What's the limit of the bottom? 0, right. So it means you can't break them up. Other ideas? Yeah.
Could you multiply the top and the bottom by sine 3 theta?
Nope. Because we get sine squared, and now we just made a bad problem worse. And say no. No is the wrong answer. You can do whatever you want. You can say, oh, let's multiply by 3x squared plus 7 on the top and the bottom. And now, yeah, that's bad news bears. But yeah, I guess you could do that. I just don't think it's a good idea. Because then we get a sine squared, and then, I mean, we break that up into 1 minus cosine squared and factor that puppy. But that's going to be ugly. Now we just made, you know, patient comes with him with a concussion. We just gave him a heart attack. Ideas. Boy, it'd be nice. Look up real quick. It'd be nice if that was divided by what? 7 theta. It would be. It'd be really nice if that was divided by what? 3 theta. Now, the problem is, can we divide by 7 theta and 3 theta at the same time? No, but we could divide both of them by what? A common, like, or Okay, hold on. Let's look for something in common here. Okay, let's go through the sequence again. Hold on. Oh, you're getting warmer. Okay, question. It'd be really nice if that was divided by what? 7 theta. It'd be really nice if that was divided by what? What do those two have in common? So it'd be really nice if they were both divided by theta, but we can't just divide stuff, so let's multiply by what? 1 over theta, right? Good. Let's multiply the top and the bottom by 1 over theta. Let's multiply the top and the bottom by 1 over theta. So now we got the limit as theta goes to 0, and this is just an algebra trick. There's no magic to this. The bad news of algebra tricks is you either see them or you don't for a large part. Sine 3 theta over theta. Is that allowed? Yeah, because 1 over theta divided by 1 over theta is just a really clever form of what? 1. Now you say to yourself, wait a minute, that's the whoa, 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 whoa. Yeah, but that's just a clever form of 1. As the top changes, the bottom changes by an equal amount. Top changes, the bottom changes by an equal amount. Okay, so let's go from there. Now, what could we do with the top? Multiply this by 7 over 7. Let's do that. Bottom, we can multiply by what? 3 over 3. Now, here's where I'm going to be a bad teacher for a second. I'm going to let you finish that one on your own at home. I'm going to let you finish that one on your own at home. Now it's just plug it in the limit and go from there. But I do want to stop and take questions. I don't like to necessarily waste class time with computational stuff, but questions on that? Okay, let me see if I can do this. Can I do this? Can I do this? Can I do this? Let's give you one other tricky one. So this is the 5th thing we know the limit of. The limit as x goes to 0 of cosine of theta minus 1 over theta. We're just going to give this to you this one, and then we define it later on in the class. That's equal to 0. Now, good news. If you took me for pre-calc, I told you theta usually means we're measuring in what? Yeah, that's a theta. That's a theta. That's a really ugly theta, but it's a theta. Good thing I wasn't on the internet.
Oh, wait. There's a projection.
Yeah, good thing it wasn't on YouTube or anything. Even though we have theta, everything in this class is in what? Radians, yeah. Rather it's a cosine of x, a cosine of theta, because I remember in pre-calc I told you theta usually means degrees, x usually means radians, everything's in radians. Your calculator's in radian modes all day long. One of the things I'll teach you to do before the AP test is make sure you're in radians, not degrees, because you'll cry when you miss every problem that has that in it. Okay, so that's just another one of those identities that we got to know. I do want to spend a moment talking about sandwiches, though. Sandwich theorem. What are we going to use the sandwich theorem for today? You used it in Algebra 2. You used it in pre-calc. You used it a lot in Calc 1 last year. Now we're just going to use it for limits. Now we're just going to use it for our friend, the limit. Now we're just going to use it for our friend, the limit. Okay, so here's what the sandwich theorem says. Let f, g, and h be continuous functions. And I'm hoping this is just, I remember this from last year. I remember it being a BFF last year, and now we're just meeting each other again. It's like we lost their Snapchat info, and now I found it again. We got to catch up. So let f, g, and h be continuous functions, which means at every point in their domain, the limit from the left, the limit from the right are equal. The functions defined at that point and the limit's equal to the value of the point of that function. Let them be continuous. And let's say that g is always stuck between h and f. So in other words, like I said, it's like that's j. It's a g. America, are you kidding me? That's a g. What comes between f and h? They're both G's, people. This is America. What comes between F and H? Freaking G. Jesus. Boy, that was clearly a G. This is a J, people. A J has a dot on the top.
Capital J has.
That was like a nice J.
Put a hat on.
I used to do that. I used to use the unit and then my P's and P's.
I get that, but here's the good news, Ayana. I am training you all to be pharmacists, so by the end of this year, you'll be able to read all the junk anybody ever brings out. Okay, so F is always between H and G. So you got to think, like I'm at, oh yes, color dance. I'm trying to dance with my girlfriend, but her annoying friend is always in between us. So then we try to ditch her and leave. Problem is, what happens? She leaves with you, right? Because she's always between you and your girlfriend. It's really awkward when you try to give your girlfriend a hug or hold her hand, and her friend's always between you. So here's the bad news. Wherever you and her are going, the friend's going with you. So here's the bad news. Now let's apply it to the limit. Let's say that the limit of f of x as x approaches 0, x approaches 8. Let's make it generic. The limit of f of x is equal to the limit of h of x. So in other words, as x gets arbitrarily close to a, both f and h are getting arbitrarily close to some limit value. Some limit value. Does it matter what that is? No, it doesn't. What do you think g is going to be going close to then? If g is always between f and h both have a limit of L, what's g's limit going to be as well? L, it has to be, right, because it's always between the two. So it's kind of like we got one above, we got one below, you're between the two. If they're both going somewhere, you're going there too. So therefore, remember those three little dots mean therefore, the limit as x approaches a of g of x is equal to exactly L as well. Now, why is that useful? Because a lot of times we got something nasty, but we can say it's always between these two things. These two things have the same limit, so we got it in between. Caleb, yes, sir?
That's kind of how you solve series and sequence with numerical.
Absolutely, and that's why I teach it right here, because we're going to see it with integrals, we're going to see it with series and sequences. This way you've been, again, a lot of the way I teach this class is I want you to think of these things that we're going to do in these really hard chapters early. Really hard chapter, you've seen this stuff before, so I'm not introducing everything. Sandwich is how we do a lot of series and sequences. Ariana.
On like the AB test, will they give you f of x?
No, what you'll do is you'll have to find the limit of something, and you can't. So you'll say, I know it's always between these two things, though, and they have the same limit. So this has to have the same limit. Like, let's take a look at an example here. Like, let's say I threw example, I don't know, I think it's 3 at you. And let's just give one that's a total train wreck. Total train wreck. X times the sine of 1 over, what should we go? Total train wreck. 3x to the 4th minus 7x to the 3rd plus 2x squared plus 7x plus 1. And here's what they say. Oh, let's give you a trivial problem. Let's give you a trivial problem. Let's take the limit as x goes to 0. Trivial. You look at it and you're insulted they couldn't come up with anything that, wait a minute, that's pretty hard. Ayana.
So for this theorem, will f of x and h of x always?
The only way it works is if they have the same limit. They're not going to be the same. Did you really just throw paper at each other? Did I land my butt in Algebra 1 today? What's that?
Pass me a note.
My middle school here? Y'all don't text?
I think you should read it out loud in front of class.
Yeah.
Yes!
Yeah, I've never been in a class that did that before.
Let's do it. I'll read it. Thank you. Let's read it.
Out loud. Can you read that?
That's hilarious. So it says, we don't know the Hopi tells yet. We don't. It's not. And then yours is, are you seriously passing guns? That's actually cute. All right, now let's talk to each other. At the beginning of the year, I told you one of the things I have to teach you very quickly is what matters and what doesn't. What matters and what doesn't. Because last year you learned like Boba Betsy, which implies that everything's important. It's not. Very few things in calculus are important. So I want you to take a look at this limit real quick and decide what is important and what is not. What is important and what is not. Talk to the person next to you real quick. What is important and what is not. Well, I did. But I thought maybe some
Okay, that doesn't make me a nerd.
Yeah. What's that? That's a time. Time. Oh, that's important. That's important. If it was a minus sign, we would be in an entirely different world. That's times. Times. I know, I shouldn't use
So that
We're not
times.
So we're taking the limit of that whole thing as x goes to 0.
It doesn't matter.
What? None of it matters. So trivial, none of it matters.
Because 0, if you just plug 0, you just
Okay,
0
Ayana.
times everything.
Ayana, why can't we just plug in 0, girlfriend? Why can't we not just plug in 0? Well, first off, what's it going to make that denominator inside of the sign?
One.
Yeah.
But,
1 over 1.
but this, the x that's by itself.
Yeah.
I thought that's more important. So then that overpowers everything else.
Oh, really? Tell me how it overpowers everything else.
Because it's by itself.
Okay, let me ask you a question. You're on the right track. Something's going to overpower something else here. What's the thing that matters and what's the thing that doesn't? Cameron.
The x on pragmatic approach 0 and the x approaching 0.
Okay.
Times anything.
Okay, really? 0 times anything is 0? Right. But we're not going to get to 0. We're going to get what?
Arbitrary.
Right. And if you remember Jenny Hall last year, Jenny Hall and Beckman had like a 3-class contest over what's 0 times infinity. And she said it's always equal to what? 0. So I just kept coming up with examples of it's not equal to 0. Now, question, are we equal to 0 or are we approaching 0? Now, be careful. We cannot use the properties of it being equal to 0 for the properties of it approaching 0. Just like infinity. Are we ever going to be equal to infinity? No. So don't think 0 times infinity is like some definite term. It depends. That needs to be in your head as a calculus. It depends how fast we go to 0, how fast we go to infinity. So you can't use that 0 times anything is 0 because we're not at 0. We're getting arbitrarily close to 0. So we can't use that. The limit never gets to 0. The limit gets infinitely close to 0. So we can't use that. But you're on the right track on what matters and what doesn't. So you say the x matters. Why doesn't the sign matter? Why doesn't the sign matter? Cameron said it. Why doesn't the sign matter? Yeah.
The sign doesn't matter because if you plug in 0 into the denominator, you're going to get 1 anyway.
No, we're not plugging 0 in though. We're getting arbitrarily close. So again, you got to think we're not getting there. We're getting arbitrarily close. You can't apply the properties of getting married to getting arbitrarily close to marriage. I know we want to in society, like, oh, we want to file our taxes together, we want to live together, we want to have babies together. No, you're getting arbitrarily close. We're not getting there. You can't assign the properties of equality to limits. Because remember we talked about all the properties of limits and they were different than equality? Because they are. Yep.
Why can't you just plug in 0? I don't understand. No, but like I don't
It's the
understand
limit.
because like for any other problem.
I understand.
It's a polynomial, but hold on. Part of it's polynomial. X is polynomial. But the thing inside of the sign is a polynomial inside of the trig function. We can't apply the properties of polynomials to a trig polynomial inside of a trig function. That's complicated. That's messy.
Okay.
But think of trig functions. Think of that. What do you got, Caleb?
The trig function, the limit is x approaching 0 of that trig function. The trig function approaches sine of 1, right? So that's a constant value.
Yeah.
But the x out front is approaching 0.
So let me ask you a question, though. Sine. Okay, Cameron, you got to get an enthusiasm.
Sine's oscillating.
Yeah.
As you're getting really, really close to 0,
Yeah.
you're actually going to be like 0.00001.
Okay.
And your sign doesn't really matter because when you're multiplying by that 0.001. So you can begin
What if it's like 10 quadrillion?
You're getting smaller and smaller.
I gave you the freaking answer, people. What if it's like 10 quadrillion you're multiplying by 0.0001? I just handed you the carrot. Now I got to do teeth now. 1. Why 1? What do you know about freaking? Take out your freaking hands real quick. This is where calculus teachers get angry because they're like, you should freaking know something about sine, but you freaking don't know anything about it. Take out your hands real quick. Graph sine y equals sine of x. Okay, tell me about it. What's happening? It's oscillating between what values? So wait a minute, real quick. That nasty thing that's in the side. A lot of students are going to look at this, and I guarantee they're going to throw something like this on the AP test because a lot of people are going to freak out and they're, holy, look at that polynomial. Like, I can't solve that. It doesn't matter because sine is going to oscillate between what two numbers? So the worst value that this sign could be is what? -1, right? What's the best, highest value this sign could give? So at worst, we're going to have -1 times x. At best, we're going to have 1 times x. Okay, now let me give you a second to think about that. At best, we're going to have 1 times x. At worst, we're going to have -1 times x. How does that apply to this problem? How's the actually, now we're getting close to a solution here. How did we actually use this thing called the sandwich theorem based on that information? Matt.
Because now we can just separate it into the limit as x approaches 0 of x and the limit as x approaches 0 of -x. And
Okay.
then find what those are, and if they both equal the same thing, then this equals the same.
Would you agree with this statement that this train wreck here is always going to be between -x and x? Would you agree with that? that train wreck is always going to be between it. Now, here's what I need to teach you in calculus. What do you have to learn? You have to learn what's important and what doesn't. Now, where did it kill me last year as a teacher? It killed me last year because I let my kids get away without learning this. And then I got to a chapter that this mattered. And they just didn't have enough experience with this, of thinking this way, of doing things this way. And then I was teaching them something there's no way they could access. That was my fault last year because I just didn't realize I had to nip something in the butt. Well, Betsy, that's fine if you remember. It's fine if you use it for the easy problems. What do you have to learn in this limits chapter? What matters and what doesn't. When you see a sine and cosine, you think that's always going between negative 1 and 1. 99, 99, 99, 99 million times out of 100 million. That's going to allow you to use the sandwich there. Because this is always going to be between negative 1 and 1. So it's going to be between negative x and x. Now here's the cool part. We want to find the limit as x goes to 0. What's that going to? 0. What's that going to? 0. If this is between two things going to 0, what does it have to be going to? 0. Does that train wreck matter? No, in fact, I just made that up. Because it doesn't matter how bad it is. Because the only thing that matters is sine goes between negative 1 and 1. And we multiply x by 1 and negative 1. As they get close to 0, what are both of those going to? So the limit as x goes to 0 of negative x is between the limit as x goes to 0 of x times sine of 1 over a train wreck. Now, this is key thinking. This is how you have to think as a calculus student. What matters and what doesn't. Series and sequences, Caleb brought that up. This is where, again, I made an error as a teacher last year because I just didn't teach them to think this way because I thought that, okay, we can get there. No, no, no. You had to be thinking this way the whole way. And it's really a disservice to you they didn't teach you this last year because when you get to the AP test, they're not going to throw stuff you've seen it before. They're going to try to take you one step further. Number 10 on that problem last night, on that homework problem, why was I so happy that Linda put that up there? Because it's one step further than what we talked about, but they love to give you that. They love to give you that. This is going to 0. This is going to 0. So by the sandwich theorem, because it is between 0 and 0, by the sandwich theorem, the limit as x goes to 0 of x times the sine of 1 over 3x to the 4th minus 7x to the 3rd plus 2x squared plus 7x plus 1 has got to equal 0. Why? Because it's between two things that are going to 0. The only way it's going to be between two things that are going to 0 is if it's going to 0 itself. Yes?
Wouldn't an easy way to do this just do the property of limits?
But I cannot use the property of limits because I do not know the limit of sine of 1 compared to the limit of 0 and which one's going to win out between the two. If something's going to 0 and something's going to not 0, we don't know the properties yet of where that's going to. It's very easy to think that the answer is going to always be 0, but can I just give you an example of one? Let me think of one from last year. Something that's going 1. Okay. Oh, well, let's just go to that one. It's really easy to say that that's going to be undefined, but the properties of limits we can't apply to the properties of equalities. Let me give you another one. Let's go limit x approaches 0 of x to the 7,000th times the sine of, no, cosine of x. Is that necessarily going to be equal to 0? Not necessarily. This is going to 1. This is going to 0. Which one's going faster? It depends. What if I put this as 1 over? So the 7,000th root of x times cosine of x. Cosine of x is getting really close to 1. This is getting really close to 0. Is that necessarily going to be going close to 0? No, that's where we use the L'Hopital because it's got an indeterminate form. That will be something we solve with the L'Hopital because the form is indeterminate. Caleb.
This discussion is approaching the limit as x approaches series and sequences.
Yep.
To determine which would be going faster,
Yep.
do you have to graph them?
Nope, use derivatives, because what's derivative tell us? How fast things are going. It tells us their rate of change. And if one is going faster than the other, and that's why, again, Boba Betsy and all that is really irrelevant once you learn L'Hopital's, because you just use L'Hopital's. If you've got x to the 5th over x to the 3rd, you take the derivative of x to the 7th, it's going at a much faster rate than x to the 3rd. In fact, you take the derivative 3 times, the derivative of the bottom is going to be going to 1. And that's why I don't even mention that in class, because as soon as we learn L'Hopital's, any need for Boba Betsy's out the window. All of them are solved by L'Hopital's. Anyways, fun day. Who's ready to go home and tell their parents? In fact, throw that limit one at your parents tonight.
Oh my God.
Be like, I'm going to give you the limit as x times the sine of 1 over huge train wreck Ask them to solve it. Woo! And then tell them you know how to solve it. Man, you will feel smart. Your parents know calculus. They just might not know that they know it yet.